Most students struggle with equivalent force couple systems because they don't fully understand what a couple is. And so before we solve this problem, let's just quickly break down what that is. Now, a couple is created when you have two equal and opposite forces that are acting some distance apart. Now, the key thing is these forces, they don't cancel each other out completely. They do cancel in terms of force, but they still create some sort of rotation. And that rotation is what we call a moment or a couple moment. So instead of moving the object, a couple tries to rotate it. Now in this question, we don't actually have a pure couple given to us, but what we're going to do is to convert a system of forces into an equivalent force and a couple. So let's start by looking at the forces acting on the beam. So we'll begin by separating the forces into horizontal and vertical direction. In the horizontal direction, we only have one force, and it's this force here, which is 20 newtons. So that's the only force we have in the horizontal direction. So what we would say here is the sum of the forces. Now I'm going to use X for horizontal direction is positive 20 newtons. And I've written this as positive 20 newtons simply because I'll take forces going to the right as positive and what's going to the left as negative. Now in the vertical direction, we have this 15 newtons right here. And we also have this 10 newtons right there. So we're going to take upward forces as positive. So what we do here is to sum the forces in the vertical direction, and taking upward forces as positive, that would leave us with a positive 15 and take 10. So what we're left with then in the vertical direction is just 5 newtons. Now always do this first, just break forces into directions before combining them. So now we're going to combine these to get the overall resultant force. And since the horizontal and vertical components are perpendicular to each other, then for the resultant we can use Pythagoras' theorem. Now, I'd just like to pause real quick just to ask you to subscribe to the channel if you haven't done so already, and give the video a thumbs up. I genuinely hate to interrupt the video just to ask you to do that, because I would prefer for you to do that on your own terms. But if you could, then I'd be very grateful. So let's get back to the calculation. So for our resultant R, that will be the square root of the horizontal component squared plus the vertical component squared. And what that leaves us with is 20 squared and plus 5 squared. And if you put that in your calculator, you'd get the square root for 25, which is 20.62 newtons. So this represents the magnitude of our resultant, and we're going to now have a look at its direction. And just in case you don't understand where this comes from, if you were to draw our vertical components and our horizontal component like that, and this here would represent our resultant R, then because our vertical component was 5 newtons, horizontal component 20 newtons, and we have this 90 degrees here, then that's why we use the Pythagoras' theorem. And we're now going to find that angle there, which we're looking at using tan inverse, because this 5 newtons represents our opposite side and this 20 newtons represents our adjacent side. So therefore, for the angle or theta, we're going to have tan inverse of the opposite, which is our 5 right here, over our adjacent, which is the 20. So that will give us an angle of 14.04 degrees above the horizontal. So that's the force dealt with. Now we move on to the moment about. We're going to take the moment about point A right here. So I'll clear this just so you can have a look at the diagram whilst I do the next half of the calculations. So far we have a resultant of 20.62 newtons at an angle of 14.04 degrees. So now taking the moment about point A, let's just analyze the forces and just recall the formula for moment, which is equal to force multiplied by perpendicular distance. So looking at the forces, the 10 Newton force, it acts 1 meter from our point A, and that's going to cause a clockwise moment. So you can see where this will try to rotate clockwise like that. The 15 Newton force, it acts 3 meters from point A, and that causes an anti-clockwise rotation like that. And the 20 newtons, it's horizontal to the point A. So that force, it does not create a moment because there is no perpendicular distance to its line of action. So the moment of that 20 newtons will be 0. So let's work these out now then. So we have the moment about point A, and for our 10 Newton force, it's just 10 multiplied by 1. So that gives us 10 Newton meters, and that's clockwise. So for the 15 newtons now, we have moment about point A still, and for our 15 newtons, it's just 15 multiplied by 3 gives us 45 Newton meters, and this is anti-clockwise. And I won't bother to include the 20 newtons because we know that's just 0. So for the total moment, so we're going to take anti-clockwise as positive for this example. So that would give us a positive 45 and a negative 10 Newton meters. So that will just leave us with 45 take 10. So the sum of the moment about point A would be equal to our 35 Newton meters, and that's anti-clockwise. So at this point we can now replace the entire system with an equivalent force couple system at point A. So if we were to state the equivalent force couple system at point A, then what I would say is the resultant force acting at A is our 20.62 newtons at 14.04 degrees. This is what we got right here. And the resultant couple moment is just 35 Newton meters anti-clockwise, which is what we have right here. So that's it, and I hope you found some value from this video, and be sure to like the video and subscribe to the channel.